Hi, I'm Walter. I'm the Dutch mentor, also known as the Flight Path Pioneers. I am a CFII helicopter and currently pursuing my CFII in fixed wing as well. And I always try to find ways to remind myself of all of the important parts and pieces of helicopter flying. And the best way to do that is by sharing back. So I'm starting a new series called a 15-minute helicopter lesson. As you can see, I'm going to break it down into several components. Today we're going to be covering just the helicopter components from the main and tail rotor transmission. And then we'll go into more sessions in the future. Why 15 minutes? Because I truly believe in 15 minutes a day, you too can learn just about anything. I'll take a practical approach to this, not just by reading some slides, but tell a kind of a story and how you can incorporate that in your lesson plan for best learning. Now, remember, best learning is very individualized. Some people need to read books, some people need to look at pictures. I'm somebody who needs to go out and actually feel and touch things. So that's the approach I'm taking. I found that as adult learners, that's probably the best way to retain information. So let's get started. So from a structural component, it's really to understand how this mechanical thing is put together that allows us to safely complete a flight. And I always reminded myself as the day when I was a flight paramedic, every time I got into the back of the helicopter, and a very trusted pilot, very capable pilots, would take off and take his place. And we were flying the PK-117 at that point in time. It is like you have a million parts moving, and all of it has to be just perfect. And, more often, 99.9% of the time I did. Of all the flying I did as a flight medic, probably over 1,000 hours, we only had a couple of times that we had a mechanical issue by having a light come on showing that there might have been a metal shaving in the rotor system. But that's really about it. So it's really amazing to think how often, how many hours we fly before something potentially could go wrong. But that's why we have a really robust program in place to make sure that these components are all functioning. Now, what is the responsibility of the pilot? Well, it's your responsibility every single time you go out to do a flight to complete a pre-flight, right? And you cannot substitute it. It is something that's critically important. You got to put your eyeballs and your hands on the aircraft itself. And that's what we're going to be talking about today on what you should be looking for as you are going to do this pre-flight. So obviously, if you look at the structure, right, of the helicopter itself, you'll see a lot of tubes and connections and joints and skin, right? The airframe is it's truly a fuselage structure that is welded steel tubing. Now, as you're going to look at the aircraft itself, you have to not look just at the mechanical pieces, but also take a light with you and look at the structural pieces, right? Look at all of the joints. Now you see that very astute mechanics will use a color pen, paint pen, either orange or blue, something that stands out on all of the critical components where screws or nuts are. So you can see if there's any loosening of that by breaking the line of those components. But equally important is for you to look at the tubes. Now, of course, rest assured that the 100-hour inspection, certainly at the annual inspection, when the skin in some areas of the aircraft that we cannot remove are removed, the mechanics are going to be looking with a fine-tooth comb over each joint to see if there's any potential crack. But again, I want you to look at that. The other thing that you will see is lots of rivets. And rivets are throughout the aircraft. That's how the skin is put together and attached to the structural frame itself. And anytime you see a rivet that is shaving, that is you see black marks trailing from it, that means that there is something not quite right. Now, one is okay, but multiple is probably not. But again, it's always best when you see something to say something, right? So the parts of the airframe, the things that are attached, welded to, and then of course you have things that are not attached to, but directly by welds, but by joints. And you have to think about the doors, the ducts, and the secondary cabin structures. And often they are a combination between metals and plastics and fiberglass, thermoplastics that are put together. But there too, you have to look at the joints. So, for example, on the 44, you have four doors. Well, Each door has 2 hinges. Each hinge has a pin, but also safety wire or some kind of clip that goes to it. I found many of them missing over time. I'm not sure it was done intentionally, but it is important that you, either when you fly with the doors on, that the pin is in and there's a safety wire to it. Right? You should not fly without that. That's just a standard you have to develop for yourself. Now, there is a separation between the cabin and the engine compartment, and that's where there is a firewall. You can look at the firewall if you open up the side cabinets to be able to look at the structural components where you will do inspections and fuel checks. You can see the backside of the firewall on that. Of course, from the cabin, it's all covered up with more leather or other kind of covering to make it look more aesthetically pleasing. But again, it is important to know that there is a separation between you, the fuel tanks, in order to give you some sense of a protection. Now, again, how strong is that? Well, depending on if you crash, that still can bend and twist and potentially cause ruptures. And remember that in the fuel tanks back in the early days, there were no rubber bladders inside. So when a hard landing occurred, potentially speaking, there could be a rupture of a fuel tank, which could cause fuel spillage and fire. Of course, they took counter actions to that and provided bladders inside of which gave an additional level of protection to that. Again, you cannot see this, but you do need to know that these are existing. Now, as you look at the back of the aircraft and you look at the exterior skin, again, you're looking at rivets, you're looking at any twist, you're looking at any kind of dents, which could all cause you to lose function or at least a weakening of the structure itself. But more importantly, when you open up the side door and you have an opportunity to look at the belts, but also look at the into the cone itself. That's why you always want to carry a light with you and shine that in that. And as you can see the picture next to it, there are structures that make the cone itself that goes all the way back in the tail. Obviously, you have the shaft that goes through the middle to the yoke flanges, right? The dampers that takes it all the way to the rear transmission for the tail rotor itself. Look for, again, anything that is abnormal, discoloration, shaving, any kind of fracture. Again, if you see something, say something, but make an effort to take a look at that. Again, small dents and fractures can become big and large. And again, the helicopter shakes, right? There's lots of movement. And I always say that as you fly, especially get into turbulent air, it really is amazing to see how it all stays together. But it only will stay together as long as you inspect it to make sure that we're not missing anything. The horizontal and vertical stabilizer on the exterior, again, we cannot look at the interior, is helping us provide more stability. Now, of course, that in a hover, when we are at a standstill, even though we're off the ground, these are not really functional and not doing much of anything for us. But in straight and level flight, they certainly do. And of course, once we get into the deeper conversations around what happens if you lose a tail rotor, the horizontal and vertical stabilizers will help you keep the tail behind you at a certain speed, right? And we'll talk a little bit that it helps with left and right yaw stability and improves the fore and aft stability as well. As you can see, Robinsons actually have updated. They used to have only horizontal fins on one side of the aircraft, on the tail, and now they're actually producing all of them with a horizontal stabilizer mid-shaft of the tail, both left and right side. They have proven that over time that provides more stability in flight itself. So as we go looking at the tail itself, it is something that needs to be physically inspected, and the best way to do that is to actually use your hands. So we'll talk about the engine components at a later time. Today is more about the physical inspection of the structural components. So one thing I always do is you can stand back and look at the aircraft itself. You look at what is there and what is not there, and does it all look aligned? Well, using your hands and going over the structure itself, you can feel if there's any rivets or dents or weaknesses, looking to see if things are in place as they are designed. Again, if you have any question or concern, again, go back to the mechanic and say something about it. Don't hold it for yourself. Next thing you want to do is to actually taking a step back and looking at the skids. Both the 44 and 22 have skids as landing gear, and they need to be symmetrical. Now, it is a little tricky. If you're not on perfect even ground, it might be slightly off. But again, if you are inspecting on a level ground, if you step back by 20 feet and look from the nose to the tail, you should see that both of the gears are symmetrical. And of course, they have been designed to absorb an impact, right? To give it a little bit of a spring, but it's supposed to spring back, not stay. So if you see one that is a little lopsided, which I have seen in the past, that could have happened during a hard landing, right? That could potentially bend any structural. Now, sometimes it's just situated in a way that once you've released the energy that's stored in it, it bounces right back to the way it should be. But again, the key is to take a look at it, because anytime you have a potential structural failure or the elasticity of that is no longer as it should be, well, that if you go out and you have a hard landing, you don't have the protections that were meant to be there for you. At the skid level itself, underneath you will find 4 to 6 skid shoes, as you can see on the right side. Now, most of the time, we're doing very careful landings with very little movement on the ground. However, we do practice auto rotations all the way to the ground, and running starts and running stops, right? Depending on weight and different circumstances that might require you that. So we have to practice that, and that will, over time cause wear and tear on the skid shoe. So it's good for you to inspect that A, is the shoe there? B, make sure that the thickness is still there. And if you see a question that, again, go back to your mechanic and ask that question, is this appropriate, right? Remember that most of us don't see this stuff. We've never touched this, right? We just, hey, this is the helicopter, we're going to go flying. But it is, again, important for the pre-flight inspection that you take these things very, very serious. Now, of course, the main part of other than the engine, which will be another lesson, we're looking at the rotor system, both the main rotor and the tail rotor system. And when it first started, it was actually done with wood, right? If you go back to the Wright brothers, for years it was all wood propellers. Of course, we've come a long ways to go to more advanced technologies that can allow these blades to last a lot longer. But these have also a time limited component to that, and that is something that you should be aware of and be able to look up in your A&P logbooks to see how many hours are on the tail and the main rotor blades, because they need to be replaced at some point in time. Now, what is your responsibility? When you go out, make sure, of course, on the Robinson design that you have 2 on top and 2 on the back. Always, and I mean, just kidding here, is that always make sure that you do a visual inspection, stand back, and see if everything is symmetrical. Are they visually looking the way it's supposed to be looking? But it's also important to be able to climb up on the aircraft, and you do that, on the right side of the aircraft, and you actually take a light and go climb up and look at very closely at the rotor head itself. Again, here it is important to be able to look at it and put your hands on it and feel. Make sure that everything looks okay and there's no any leaks that are taking place, or if the lines, the mechanical lines with a paint pen, are still in line. Mind you, this is spinning at several hundred revolutions per minute. So it's very, very important that everything is together. What they call the Jesus nut. Well, that's just one of the components, right? There are many components, as you can see on the side. You have the blade grip, right, where the blade is attached to the rotor head itself. You have a coning hinge. You have a teeter hinge. You have blade pitch horns and pitch links and a swash blade. Again, all of these terms, just reading about it is hard to comprehend what it is. So get on that aircraft and take a really good hard look and feel and touch it and see. Now, the best thing to do, and my recommendation is, have somebody else sit in the aircraft itself and manipulate the cyclic and the collective and watch how things actually work. Right? And that's really the biggest transfer of knowledge that you can make for yourself, to really see, what does a pitch horn do? What are the pitch links? What happens when I pull collective and I see the swash plate coming up and down? What happens when I move the cyclic around and I can see that there's a change in the blade? Again, these are important pieces of the mechanical function that you need to put into your head. We talk about precision all over the time, right? An input is only felt 90 degrees later. Well, get on that aircraft and take a look at it where you see the pitch link and the pitch horn change is offset by 90 degrees. Right? The best way to see it is by having somebody in the aircraft manipulate it so you can actually see. And that is how you go forward and backwards and sideways and left and right. Right? The collective goes up and down. It changes the angle of attack of the blade itself without changing the rotor head itself. Again, very interesting stuff. And if you have a mechanic who has saved the rotor head in the mechanic shop, spend some time with that. Right? It's really, really interesting for learning and transferring knowledge into your head itself. So there's lots of great video clips online around the swash blade. So I'd encourage you to go and just look it up. And it just to get to understand how this works, because there's two components. One has to be fixed and the other one is rotating. And how do we transfer information between the two of them, right? Because these are dependent components. And that is something that, intuitively doesn't always make a whole lot of sense. But seeing it up close, and you can't put your head when the rotor is spinning fast, sitting on top, looking at it while somebody's manipulating the controls is certainly one way of doing it. Going to YouTube clips where you can actually see this mechanically in action, or look at some animations will help you understand what it is that you actually do when you are flying the aircraft itself. The structural components, listen, it's no longer wood, right? And they come in different diameters and different lines on between the R22 and R44. So for your check ride, be familiar with these things, right? Understand on how this is actually built, and it's not dissimilar to having a wing of an aircraft, right? And understand what the function of the rotor, the advancing blade is versus the trailing blade is. And that's a little different from aircraft flying, and that's something that you have to try to wrap your head around. But the key thing is that these were all made in a way that these are very structurally hard from a medical composition, aluminum, honeycomb interiors, right? It's hard, and as you can see in the top right picture, is that the leading edge is actually reinforced itself. Now, what are we looking for? Is that we want to make sure that the blades look normal. Now, there is some wear and tear and some paint that can disappear over time. Of course, every time the advancing blade goes around at a high speed, it can hit bugs. It can sometimes be exposed to rain and other wind. So over time there will be damage, and that's part of the reason why this component is life limited. But it is something that is that you will pick up on. On the bottom right hand corner, a delamination is possible. Rare, but possible. And it is your role to look at the root all the way to the tip on both of the blades, on top as well as the tail rotor blades, to really understand, to see if these are in place and intact, including, again, all the mechanical hinges, and play with this stuff. Now, you can see the word underslung at the teeter hinge. And again, when you look at the rotor, tail rotor, or the main rotor itself, you can look at this and to see what that means. Now, again, the best thing to do is ask your instructor to go up there and show you what it is. And you will see these little mass bump pads, the plastic one, to kind of see what that means and how it all works. But that is, it helps you with getting the understanding of one thing that you learned, of course, early on in your SFAR 73 about low G pushover and how we can potentially have mass bumping. Again, the underslung component is piece of that puzzle. The tail rotor component, of course, is close. You can stand outside and take a look at it. There are some minor differences between the main rotor and the tail rotor, and that is something that's really interesting to see, that there's a fixed angle of attack, angle of 1 degree, 11 minutes, on the tail rotor. So if you're sitting on the ground, it's already at an angle that helps the nose to keep it straight without any mechanical, as long as your paddles are neutral, right? It's very, very important. As you start up, they're always in neutral position. If not, the nose will start swinging. And if you want to see some crazy online videos, take a look at that. There's been some excellent. Luckily, most people walk away from it, but it is really, really important to make sure. Again, trying to understand how the rotor blades are creating thrust in order to be able to have the counter, right? It is everything, the rotor is a counterclockwise. So of course the nose wants to go in the opposite direction. We need to offset that, right? And the preset of the tail rotor is already helping us out with that. All right, that's it for today. I hope that you found this beneficial. There's nothing that you can substitute from a great pre-flight. Walk around touching, feeling, and seeing, and keep asking questions on your CFIIs. Right? It is their responsibility to transfer this knowledge of what you see, what you feel, what you understand, into really deeply understanding. And the way my father always told me, see one, do one, teach one. That's exactly what I'm trying to do today, is try to transfer that knowledge, not only for you, but also to remind myself of all of that. Thank you. Come back again. Come check me out at Flight Path Pioneers and share it with your peers.